Okay, so today we're talking about this, the humble rubber band. It seems so disposable, totally insignificant. But this simple little loop holds a secret. It holds a strange physical paradox that not only makes our entire modern world possible, but it might also hold the key to a global catastrophe. So how does that work? Let's get into it.
First up, a little physics pop quiz. Let's say I take a rubber band, I hang a weight from it to put it under tension, and then I hit it with a hairdryer. What do you think happens? I mean, pretty much any other material, metal, plastic, whatever, it gets weaker and it stretches when you heat it, so the weight should drop, right? Well, just watch this. The rubber band actually contracts. It pulls the weight up, the absolute opposite of what you'd expect.
And this weird little property, it is so much more than a party trick. It's the key to a material that is so essential that if it suddenly disappeared, it would trigger, as one expert put it, a complete global societal meltdown. So, how do we get from a shrinking rubber band to the end of the world as we know it?
That bizarre contraction we just saw is really a window into the one-of-a-kind molecular structure of rubber. This ability to get stronger under certain conditions, when you combine it with its insane elasticity and durability, has made it one of the most critical materials on the planet. Honestly, we've built our entire world on it, and most of the time, we don't even see it.
Just think about your day. The tires on your car, on the bus, and especially on the airplanes flying over your head, all of them depend on natural rubber. And so do the seals and hoses in your home, the belts inside your appliances, the suspension systems in trains, and even life-saving medical gear like surgical gloves. It's like the hidden, stretchy skeleton that holds our infrastructure together.
So, what is it that makes this stuff so special? To really get it, we need to zoom in. I mean, way, way in, down to the molecular level. The whole secret lies in this jumbled up mess of incredibly long, tangled chains.
You see, rubber is what we call a polymer. All that means is it's a giant molecule made of smaller repeating units called monomers. And when I say giant, I really mean it. To give you some scale, if every atom in just one rubber polymer molecule was the size of a tennis ball, that single chain would stretch for kilometers. It's just massive.
So why does it snap back so powerfully? Well, at rest, all those huge chains are just coiled up in a totally disordered mess, kind of like a bowl of spaghetti. When you stretch the rubber band, you're physically forcing those chains to straighten out and line up, which is a very orderly but a highly improbable state for them to be in. The second you let go, the constant jiggling and bumping from surrounding air molecules just knocks them right back into their tangled, chaotic, and much more likely state. It's a constant battle between order and chaos, and, well, chaos always wins.
But wait, there's another layer of genius in its design. The way the little monomers are linked together, it's called a cis attachment. It forces a natural kink, a sort of wiggle, into the polymer chain. This means when you pull on it, the chain has to unfold all those little wiggles first, even before the whole chain starts to straighten out. This is what gives natural rubber its unbelievable, almost cartoonish stretchiness.
But for all of its molecular magic, raw natural rubber had a huge, fatal flaw. And it took a totally broke, completely obsessed, and honestly an incredibly unlucky inventor to just accidentally stumble upon the solution. You see, in its natural state, rubber is just awful with temperature changes. Back in the 1830s, there was this rubber company that sold thousands of dollars worth of waterproof boots and coats. The problem was, when summer came, all of them melted into a stinking, gooey, rotting mess. The company had to secretly bury the stuff at night. It was that bad.
And that's where Charles Goodyear comes in. After his first business went belly up, he became obsessed with fixing rubber's temperature problem. He was so broke that he was thrown into debtor's prison over and over again. And while he was there, he'd have his wife bring him raw rubber and a rolling pin so he could keep doing his experiments in his jail cell. The guy was just relentless.
So, after years of getting nowhere, Goodyear bought a patent for a process that used sulfur. Then, one winter day in 1839, he accidentally dropped a glob of his sulfur rubber mix onto a hot stove. He figured it would just melt into goo like always, but instead, it kind of charred and hardened up like leather. In this amazing flash of insight, he nailed the sample to his doorpost overnight in the freezing cold. The next morning, it was still perfectly flexible. He had found it. This process, eventually called vulcanization, was the answer. What Goodyear had discovered was that when you heat rubber with sulfur, you create these little chemical bridges, or crosslinks, between those long polymer chains. These bridges are strong enough to hold the chains together so they don't melt into goo in the summer, but they're flexible enough to stop the rubber from getting hard and brittle in the cold.
So Goodyear had done it. He transformed rubber into the stable, world-changing material we use today. But in a really tragic twist, he spent the rest of his life fighting patent infringement and died with over $200,000 in debt. That's about $7.7 million today. The famous Goodyear company that bears his name, yeah, that wasn't founded until 38 years after he died.
Goodyear's discovery kicked off a global rubber boom, but the race to control the world's supply of it created a totally new hidden danger, a ticking time bomb that was planted over a century ago.
See, originally, all natural rubber came from wild trees in the Brazilian Amazon, but in 1876, an English biopirate, basically, smuggled 70,000 rubber seeds out of Brazil. Those seeds were used to create these huge plantations in Southeast Asia, and you can see the result right here on this chart. In just 30 years, Brazil's share of the market completely collapsed, and Southeast Asia became the world's rubber empire.
So why couldn't Brazil just make its own plantations and compete? Well, here is a chilling warning from history. In the 1920s, Henry Ford wanted to break the British rubber monopoly, so he tried to build his own giant rubber plantation, a whole utopian city called Fordlandia right back in the Amazon. It was an absolute epic failure. Why? A native fungus called South American leaf blight completely destroyed it.
Here's the thing. In the wild, rubber trees grow hundreds of meters apart from each other. That distance naturally stops diseases from spreading. But Ford, he planted his trees in the dense grid, a monoculture, with their roots and leaves practically touching. For the fungus, it was an all-you-can-eat buffet. The blight just ripped through the plantation like a fire front, leaving a wall of dead, black trees behind it.
The story of Fordlandia isn't just some interesting historical footnote. It is a direct preview of the catastrophe we are facing right now, but on a global scale.
And this is the crucial point. Today, over 90% of our natural rubber still comes from those same plantations in Southeast Asia. And practically every single one of those millions of trees is a genetic clone, all descended from that small handful of seeds smuggled out of Brazil. What that means is we have a global monoculture with almost zero genetic diversity, and critically, absolutely no natural resistance to that South American leaf blight, which, by the way, still has no cure.
Now, you're probably thinking, hey, can't we just use synthetic rubber? And yeah, we did develop it during World War II. It's fantastic for some things, like the tread on your car's tires, because it resists abrasion really well. But for the most critical, high-stress jobs, it just can't compete. It has a lower tensile strength, and it builds up way more heat. For something like an airplane tire, that's a fatal flaw. This is natural rubber's superpower. It's something scientists have never been able to perfectly copy. It's called strain crystallization. As you stretch it, those long polymer chains align so perfectly that they actually form tiny, hard crystal structures inside the material. So if a small crack starts to form, it runs right into one of these crystals and just stops dead. The material literally gets stronger and tougher right at the point of stress. This is exactly why you cannot land a 600-ton airplane on synthetic tires. It's just not possible.
And that brings us right back to our ticking time bomb. The fungus that wiped out Fordlandia, it's still out there, mostly contained to South America, for now. But all it would take is one contaminated shipping container, or one careless traveler, to bring it to Asia's totally defenseless plantations. So, knowing that we've built our entire global transportation system, our entire way of life really, on a single vulnerable plant, are we just repeating Ford's exact same mistake, but this time on a global scale?